The purpose of every industrial fan is to move gas or air through the fan. So air comes in at the inlet of the fan on the other side, and then it comes out through this outlet. So what you get at your outlet is an outlet velocity. Depending on the amount of CFM that's going through, you're going to have a really high velocity or you're going to have a really low velocity. So as air comes off the outlet of the fan, you're going to have your highest velocity profile at the very outside of the housing because air has come really fast around the volute and out here. So it's very fast here, but down at the very bottom of the outlet, in this example, your air is still curling and it can curl back into the outlet. So your profile is very fast here, very slow down here. So how will that impact performance of your fan in your system? It depends on how high the velocity is. So you want to give your gas a path for it to normalize off the outlet of the fan. So you can do that in a number of ways. First of all, you can continue along this natural évasé that we see right here built into the outlet of this fan by putting another évasé on the outlet, and that will allow the air to continue to develop into a normalized flow a bit faster. You can go into 2.5 times equivalent duct diameters for the first 2,500 feet per minute of velocity out the outlet, and then increase that by another 1 duct diameter for each additional 1,000 feet per minute. So for example, if you have 5,000 feet per minute velocity coming off your outlet, you'd need an equivalent duct diameter of at least 5 times the area of your outlet in order for that gas to normalize its flow before it continued on in your system or exited to atmosphere. If you don't build in something that allows your flow to stabilize like that, what you'll get is a system effect. So the curve that you received for your fan's performance will be impacted by the effect of not allowing flow to normalize out the outlet, and you'll have a resulting curve that starts to taper off of your original curve, especially as it moves to the far right portion of the curve. And that's called a system effect because your flow isn't able to normalize the way that it did it in its test environment when that curve was produced. So the higher your velocity, the longer your stabilizing needs to be in your duct work before you move on into the rest of your system.